Hey, hi guys, welcome to the part 2 of the classification of elements, the periodic table. Welcome to the Chemistry Life channel, and I'll start today's part 2. Okay. Note, this law is true only for the elements up to calcium. Okay, we have discussed up to here, and we need to know the limitations of the Newland's law of octaves. So, limitations are the two elements are filled into the same position cobalt, nickel, platinum, iridium, cerium, lanthanum, etc. Some dissimilar elements are placed in same group. See, I am telling you that every maximum scientists do this same mistake. It means they place it the different, dissimilar, or different elements in place in same group. So, cobalt, nickel, palladium, platinum, iridium are placed along with halogens. Halogens are the last second group, and guys, yeah. So this law is not valid for elements having atomic masses greater than calcium. So it's valid for up to calcium. That's it. After calcium, it's not valid. है ना? Newland's periodic table contains 56 elements. On that time, 56 elements were discovered, and he didn't leave any gaps for new elements. So see, Mendeleev lived some gaps for he thought that some new elements will come in the future, so he left some gaps, but in this new land didn't even lived anything. So this is one of the limitation of Newland's law of octaves. And next, Lothar Meyer. So Lothar Meyer and Mendeleev Russia quite independently identically showed the connection between the periodicity of properties and atomic masses of elements. So see, in that time they have all in the thought of atomic masses, atomic masses, atomic masses. But Moseley, the modern periodic table father, he thought that he think the very unique. It mean it's just belong to atomic number. Okay. Let's see about Mendeleev's classification of elements. Periodic row, है ना? The physical and chemical properties of the elements are periodic sanctions of their atomic weights. He done about all the atomic weights. So Mendeleev had Mendeleev's periodic law. The physical and chemical properties of the elements are periodic functions of their atomic weights. It means that electronic configuration is just based on the atomic weights only. In the point of view of the Mendeleev. And now Mendeleev's periodic table is also known as short form of periodic table. Okay, it'll call like this. It's not bother about it. The first three periods are short periods and remaining are long periods. Each long period has two rows. Each long period has two rows of elements or two series of elements. Right, guys? Yep. Vertical columns are called groups, and they are eight groups. Horizontal row are called periods. ఇక్కడ చూడండి. The first three periods are short periods and remaining a long period. है ना guys? तो समझ आएगा? हाँ. Please like करो. Okay. Each long period has two rows of elements or two series of elements. So vertical columns are called groups and there are eight groups. And horizontal row are called periods and there are seven periods. At the time Mendeleev did some on periodic table. It's known as short form of periodic table, and it is in the group eight groups are present and seven periods were present. And guys, 1 to 8 he also subdivided subdivision of AB subgroups also. Okay, he done that. Mendeleev has a force right to leave some gaps in periodic table for three elements, and those elements are discovered later and included in the table. So those three elements are now we are reading scandium, zirconium, gallium. So these are called as ecoboron, ecosilicon, ecoaluminum. So in the point of view of the Mendeleevium, he thought that these names are just related to these. So it means C, scandium, boron, absolutely same property. Silicon, germanium are non-metals and they have similar properties. Aluminium was turbulent and gallium too, and it's room it's I mean it can melt, yeah, it can melt in room temperature too. They have very similar properties of boron, silicon, aluminium with scandium, germanium, gallium respectively. So we can appreciate and applause the Mendeleev. Next, Demetres. Some elements with higher atomic weight were placed before low atomic weight element in order to maintain similar chemical nature of elements are called inverted pairs of anomalous pairs. Anomalous pairs of Mendeleev's periodic table are okay. So these guys, okay na? These one. Position of hydrogen was not made clear. Position of lanthanides is uncertain. No plus for noble or inert gases. Absence of similarity in the groups. So these are the Demetrius limitations. है ना guys? So guys, please comment me if anything you want to say for me, and I can do my best. Okay. This is the limitations of the Mendeleev. Okay, of the Mendeleev we can get the limitations. What are those? Two elements are filled in the same position. Two elements were filled in the same position. It's these. We have already discussed before here. It means here of the limitations of Newland. So as like same at the Mendeleev also done this. So Mendeleev, some dissimilar elements are placed in same group atom. So these are placed in same group. These are the dissimilar elements. These are placed together with halogens. Same mistake. So this law with same of Newland's law of octaves. And this is the Mendeleev periodic table. Mendeleev constructed a periodic table on the base of atomic weight or atomic mass of elements. You see, you knew about it. I already discussed with you. And Mendeleev periodic law, the physical and chemical properties. I remind you, and before I have told you that Mendeleev periodic law is just based on the atomic weights. It means about mass. है ना? And next, Mendeleev periodic law consists of 8 groups and 7 periods. Mendeleev's periodic law is called short form of periodic table. Yeah, that was really amazing. And next, achievements of Mendeleev periodic table. So he have achieved some. What are those? Groups and subgroups. क्या बेटा? बोलो. Groups and subgroups. So vertical columns in periodic table are called groups. The vertical क्या है? This is the vertical. The vertical columns in the periodic table are called the groups, and the periodic table consists of 8. क्या बोला? 8. 8 groups. These are called the A, B, and subgroups. So the elements in the same group have similar properties due same valency. So group. Okay, Nana, it's very important in the examination point of view. What's mean? Group just depends on the valency. Sorry, valency depends upon the group. What's the group number? It's just related to the valency. So I can give you the 100% sure about it. The elements in the first column react with oxygen to form compounds with general formula. So this is the general formula R2O. Even this is Li2O. Yes, lithium oxide, sodium oxide, potassium oxide. See, one thing I need to say for you, for only the A group in the modern periodic table, only the A 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A are the only the valencies of the specific elements. The middle part one get electronic configuration and we can get the valency. Yes, right. The elements in the second column react with oxygen to form compounds with general formula RO. It's mean like this. Means he have get lattice of second and first columns react with how and how, what and what, है ना? Subgroups 1A elements lithium, sodium, potassium, plum, cesium, francium, pb क्या है lead, okay, are called alkali metals, okay, and experience. The horizontal rows in periodic table are called the periods 1 to 7. Elements in periodic differ in the properties. And guys, so predicting the properties of missing elements. So it means Mendeleev left blank spaces for some new elements would be discovered, and these elements are called Eka elements. We have all discussed in before Eka boron, Eka aluminium, Eka silicon. So these are the scandium, gallium, and germanium. And it's very important. It can get some bits too. Bits లో కూడా రావచ్చు. है ना guys? Yeah. I think so. सिर्फ ठीक है ना? तो समझ आएगा का कमेंट करेगा. The melting point of gallium is 30.2 degrees Celsius and melts in human and 37 degrees Celsius. Hence, this is called summer liquid. Yeah, next. Correction of atomic weights. So Mendeleev corrected the atomic weights of elements like beryllium, indium, and gold in order to place the elements into the correct place according to their properties. So the following relation is used to correct the atomic weights of the elements. Atomic so see guys, atomic weight is equals to equivalent weight into valency. So not only this, for the competitive exams also it's very important. So I'm giving you sure that every examination can get this point. Okay, next Mendeleev thought that the atomic weight of beryllium is 13.5, but he correct has 9 by using 4.5 equivalent weight into 2. And guys, so he done like that. He done some disturbances in the periodic table, so he this was rejected by all. Anonymous series Mendeleev accepted the inversion of the order of increasing atomic weights which facilitates the correct position of elements. Okay, guys, today the class was over, I think so. And now I need to say for you the Mendeleev not only. रुको. So Mendeleev is not an Mendeleev not an uh, a common man. He get all the benefits and he get all the praises from their seniors, their universities, and he got a good name of the world. Because even though Mosley done the modern periodic table, the Mendeleev is the father of the chemistry forever and ever. I to get in my point of view, Mendeleev is the father because without Mendeleev's thought, the modern periodic table the won't be. See, even no basics, no English. Even in the no English, see guys, for everything basics will be the basic of the periodic table of the chemistry. The chemistry life was starts from the periodic table. It starts from Mendeleev. And guys, he's my father. I think like that. I love chemistry and please subscribe to my channel Chemistry Life. Hope you will.